Hello, this is Tyler Moore from the University of Tulsa. Today we'll be talking about security metrics. How is it that we measure information security? Here's the overall outline for the lecture. In this video, we'll just be talking about the first bit, which is how to manage security investment. In particular, how can we measure costs and benefits in a consistent way? The idea here is that it's very important for us to frame our decisions about information security using business language, and often that means thinking about how investments can be justified, how they will either reduce costs or produce benefits. And security investment decisions are like any investment decision a business must make, and they have to balance the expected costs of an intervention against the benefits that could be received. To model rational decisions, as we're trying to do in an economics class, is to we would like to do this in a way that is realistic, but is also tractable. And so, even though in this class we've been emphasizing that attackers are strategic, for simplicity, the metrics we'll be talking about assume that the adversary is not strategic, that they're instead just given to us, and they follow a predictable behavior, and from that we can describe probabilities of attack. So, in a certain sense, we are reducing security to a safety problem. So, it's worth asking any time that you decide to make a simplifying assumption, and you're modeling to consider the circumstances when this is appropriate and when it is not. So I think this simplified model of adversary behavior is more appropriate in a case where we have indiscriminate attackers, like cyber criminals who just send out phishing emails to millions and millions of users. They're not necessarily being strategic about which target they select. They're just targeting everyone they can. It's likewise with scanning and attacks like that. Now, but there are other cases in which a strategic adversary is important to consider, which is things like targeted attacks, where the attacker is selecting a particular target based on a characteristic of that target. So, if we're going to talk about measuring the costs and benefits of security, we need to think about what the costs and benefits are. So costs can be broken up into a number of distinguishing categories. You could look at direct costs, the cost of having to implement a security mechanism. But then there are also indirect costs of a security mechanism, say the inconvenience that it might impose on users, or how it might cause additional slowdown in workers' productivity. So that's one way of differentiating between cost types. Another is think about variable and fixed costs. So there's a fixed cost, is just an outlay of money that you spend, but you spend it once. And that it's not so much that you spend it once, but that it's a certain amount. Whereas a variable amount, you don't know exactly what you're going to be spending. Depends on certain inputs. Then we have one-time versus recurring costs, which is what I was initially alluding to. And finally, we have a distinction between sunk and recoverable costs. So sunk costs are a cost that you spend, and once you spend it, there's no getting it back. So you can think of like the cost of labor. So the cost of employing IT staff, you employ that IT staff for a year, and then at the end of that year, there's no recovering the money that was spent there. But other costs are recoverable, especially investments into infrastructure. Buildings can be sold, often network equipment can too. So we have lots of ways of thinking about costs, but the big question is how can we consider benefits of security? So you may know how much you pay for a firewall, but how can you actually quantify the benefit that firewall brings you? Well, the approach we're taking in this course is to flip the cost on its head and say that the benefit we get from security is the amount of loss that we prevent by adopting the security mechanism. So rather than try to think about sort of modeling often very fuzzy concepts like improve trust within the organization. We're just going to sidestep all of that, and we're going to say the benefit we get from security is the reduction in the cost we would have had from lower levels of security had we not made this investment. So how do we define cost of security then? Well, the cost of security, we're going to call it C, is the amount spent to reach a security level called S. So, and there's some basic consistencies here that we need to do for baselining's sake. So if you make no investment in security, or C is 0, that is going to imply that the security level is also 0. And any time you're making a positive investment in security, so you're incurring some cost, that means that the security level also has to increase monotonically in C. So what we're excluding is the possibility that you spend a bit more on security and your actual security level goes down. We can have a further stronger assumption, say, of effective security investment, where if a security investment is effective, that means that we can just approximate the cost of security to the security level. So in this sense, there's a direct mapping between what you spend and how secure you are, which in certain circumstances are okay, but maybe in other cases not. So can you think to yourself about cases in which the effective security investment definition applies and when it does not? We can discuss in class some of your ideas for that. So security benefit. Again, this is the reduction of losses incurred in the absence of security. So in other words, we're going to spend some money on security. We're going to incur a loss, a small fixed loss now, and in doing so, we're going to reduce the chances of a larger uncertain loss down the line. And the good news is from our previous class, we now have the tools to deal with uncertainty about what outcomes are likely to occur. We can just apply expected utility theory directly to help measure security benefits and costs. Here's an example, which you've already seen, but not in this context. So we have an expected utility function where we're calculating the utility of a certain action, and then for the discrete case, we just sum over all the outcomes and get the expected utility for each outcome, given the various probabilities of the action. So in this graph here, we have 2 outcomes. Outcome 1 is no attack. Outcome 2 could be an attack. And then we have probabilities assigned to each. So outcome 1 has probability 0.9. Outcome 2 is probability 0.1. Of course, if you have a discrete function like this, you can, if you imagine that instead of just having a finite set of outcomes, if you have a continuous possibility, then that could turn this expected utility into a continuous function, like so. And all you've really done is to replace your summation with an integral. And that allows us to then define what a loss distribution function is. So a loss distribution function is just a function that maps from positive real numbers onto a probability between 0 and 1. So the function is mapping a loss amount to the probability that that loss is going to occur. We're going to define a couple of special loss distribution functions. L0 is the sort of the baseline one. It's the loss distribution function where you don't make any security investment. And then our benefit of security can simply be calculated as the difference between the loss distribution function with no security to the one where you invest at a security level of S. And now one thing to note here is that we are measuring losses as positive numbers. Okay, so because of that, the benefit of security would occur, so where you have your loss at a security level should be lower than in the case where you have a loss that is under no security, which is why the definition of benefit here is L0 minus LS and not the other way around. And then we can use expected utility to compare the outcomes for these different loss functions. So let's start with the discrete case again. So let's say we have a case here where there's two outcomes. You either experience a $2,000 loss or a $0 loss, and the probability of a $2,000 loss is 0.2 and of no loss is 0.8. And you can just compute the expected utility just as we've done previously. But you might say if you then invest in security, then for these two outcomes, maybe the probability of experiencing a $2,000 loss falls to 10%, which would necessarily mean the loss under security investment rises to 90%. Okay, that concludes our discussion of costs and benefits of security.